This is chapter 5. We're starting chapter 5 all about inequalities, and this is lesson 1 where we are going to solve an inequality by using addition and subtraction only. So that should help kind of open things up for you, and then you'll find that multiplying and dividing seem much easier after you know how to add and subtract. Okay, so remember, an inequality has an inequality symbol, right? So we have greater than, you could have greater than or equal to, less than or equal to, right? So we have more than one solution. When you solve an equation, it has an equal sign. There is one equation that requires one solution, right? So you get an answer that's like x equals 4, and 4 would be the only answer. For an inequality, it's saying that one side has to be greater than or equal to, or maybe less than or equal to the other side, right? So it actually has a lot of answers that could make it true. It doesn't have to just be one solution. It could be a lot of solutions. So we're going to talk about how to solve that, right? Using addition and subtraction. This is going to be broken up into 2 videos. So this is part 1. Okay, so we're going to do this first example here. This is for addition. We have x minus 8 is less than or equal to negative 6, okay? And once we solve, then we have to graph the solution on a number line. So here, we start off with our inequality. We're going to treat this inequality symbol just like an equal sign. So whatever we do on one side of the inequality, we got to do the same thing on the other side to keep them level, right? So here, to get x by itself, that's my goal, just like in an equation, I have to get rid of minus 8. So I'm going to add 8, and that's what they do here. And they kind of wrote it out to show you that step. So they added 8 on the left, and whatever you do on the left, you got to do the same thing on the right. Once they do that, negative 8 and positive 8 cancel each other out. They're just 0. And this negative 6, when you add 8, becomes positive 2, right? So you're left with x. Bring down your sign, it stays exactly the same, and then over here you get positive 2. So x can be any number smaller than 2, or it could be equal to 2, right? That's your solution. It's not just x equals 2, it's any number. So it could be negative 45, it could be negative 57.5, anything smaller than or equal to 2. When we write this as a solution set, which is weird, we never really do this, but if you see it on a test, at least you'll know. When we write this as a solution set, this is your solution, and you're going to draw a line right here, x right here, because that's your variable. It's just saying your variable x has this solution, and then you're going to put these little squiggly lines on the outside, right? So the solution is a set builder notation for blah, 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 blah. This is our answer, but this is how you would write it out, okay? How do I graph that? On your number line. Honestly, for me, when I graph these, I draw a line. I put my number in the middle, so my answer is 2, so I'm going to put a 2 in the middle. I don't put any other numbers on the number line. I know my number line goes up in this direction, down in this direction. You always put a circle on your number. If your inequality symbol in your answer has the line under it, like that, you're going to shade in this circle. If it does not have the line under it, if it's just like this with no line, that means it has to be less than 2, but not equal to 2. It can be 1.9, but it can't be 2, right? So you wouldn't circle, you wouldn't shade this in, you would leave it open if there's no line under this. But in this case, it is. Okay, and so then the trick is, as long as you have your variable first on the left, it can't be 2 is greater than or equal to x. This would be the same answer as this, but I just reversed the order. X has to come first for this little trick to work. This is the arrow trick. To know which way to shade, because you're going to shade all the other numbers on your number line that could be an answer, you're just going to turn your inequality symbol into an arrow. The arrow is pointing this way, so you're going to shade this way. Another way to think of it is, what does your inequality symbol look like? Here's our answer. Which way is that pointing? Look at that arrow on your number line. Which arrow matches that sign, right? This one. This arrow is opening up the opposite way. It's opening up this way. This arrow looks the same as this, okay? So you're going to shade that direction. So this is our answer. This is what they've done here. The only difference here is they actually started with a whole number line. They used a bunch of numbers and they shaded too. When I draw my own graph, I just draw a number line, I put my solution in the middle, and then I either shade or leave it open, and I have to shade in the correct direction. Okay, so let's do a few examples solving for these. That's addition. We're going to do subtraction in just a minute. Actually, I have another example of subtraction. That's okay. We'll hit it up here. Okay, so t minus 12 is greater than or equal to 16. Same kind of problem, right? We're trying to get t by itself. We treat this like an equal sign. So we're going to add 12 here. So I got to add 12 here. These cancel. So I'm left with t. Bring down my symbol. Don't change it. Just bring it straight down. 16 plus 12 is 28. So t can be any number bigger than 28, or it could be equal to 28, right? So on our number line, we got to shade that in. So I'm going to find 28. I'm going to put a circle around it. Can I shade that circle in? This has a line under it, so yes, I can. And then how do I know which direction to shade? Turn this into an arrow. Which way does the arrow point? This way. So I'm going to shade that way. You're going to shade all your numbers that are bigger than 28. Right? And this arrow right here looks the same as this opening right here is like your inequality symbol, right? It looks the same as ours here. Okay, so you know which direction to shade. Next one, number 2. N minus 12 is less than 6. So we're going to add 12 here, add 12 here. These go away. N is less than 18. All right, so we're going to go on our number line, find 18, put a circle there. Do I shade in that circle? Can n be 18? Does that include it in my answer? No, it's not. So I'm going to leave it open. There's no line here, so I leave the circle open. And then how do I know which way to shade? Well, it's all the numbers less than 18, right? If I turn that into an arrow, I'm shading this direction. So I shade all the numbers smaller than 18. And this arrow down here matches this symbol. This one here, right? They match. Okay, and number 3, 6 is less than or equal to g minus 3. Now this one we're going to have to pay attention to because our variable is on the right. And before we graph, we want our variable to be on the left, so we can change that over easy. I still want to get g by itself, so to get that alone, I need to add 3. And I got to do the same thing here. These go away. And I'm left with 9. Oops, 9 is less than or equal to g. That's unfair. They made them look the same. Okay, so then I want to flip-flop it, right? So I'm not changing anything now. I'm not doing any math. I'm just literally rewriting this. So I'm going to put g here. I'm going to put 9 here. I flip-flopped them. And then which way is the mouth opening? Towards the g. So down here, when I flip-flop the sides, I still want the mouth opening towards the g. So I'm going to flip-flop the mouth. Right? This is the same as this. This is saying g is greater than 9. 9 is less than g. This is saying the same thing. G is greater than 9. 9 is less than g. We just want g first. Okay? So that's our solution. And then to graph it, I'm going to find 9 on my number line. Put a circle. Can I shade in the circle? Yes, I can, because g can be bigger than 9 or it can be equal to 9. So 9 is part of my answers. And then which direction do I shade? That way. Do not forget to shade. Also, pet peeve of mine, and it is incorrect if you do it this way. Some students, when you have your number line, you get your number line, right? And it has like, let's say it's the number 4. Okay, here's the arrows. 3, 2, 5, 6. And let's say the answer is 4. Let's say the answer is x is greater than 4. Okay? Please do not put a circle up here and do this. That is not the solution. You have to actually put it on the number line and shade. I know some of you guys prefer it this way. That is not correct. You actually have to shade your number line, just like I'm showing here in the notes. You can't write it up above the number line. Okay, number 4, I have n minus 8 is less than negative 13. To get n by itself, I have to add 8. So I'm going to do the same thing over here. These go away. N, bring down my sign, don't change it. negative 13 plus 8, if I'm down in a hole 13 feet and I come up 8 feet, how far am I still down in the hole? Negative 5, right? So on my number line, I'm going to find negative 5, put a circle. Can I shade that circle in? No, I cannot, because there's no line here. N can't be equal to negative 5. That would not make this equation true. But it can be anything smaller than negative 5. So it could be negative 5.00001. That would count, right? It just can't be negative 5 itself. So we leave this open, and then which direction do we shade? To the left. All of this. Do not forget to shade. Okay, next one, number 5. Negative 12 is greater than negative 12 plus y. So it looks to me like y is going to probably have to be 0 here. I'm going to add 12, add 12. This is 0 is greater than y. All right, and we're not doing any extra math here, but we see that y is on the right. I want it on the left, so I'm going to flip-flop my terms. And since I switched the terms here, the mouth is open towards the 0, so I want to leave it open towards the 0. So here's my answer. I'm going to put a dot on 0. Can I shade it in? No, I cannot. There's no line here, so I can't shade it in. And then my thing is shaded to the left, this way. Y can be any number less than 0, so all the numbers to the left of 0. All right, and then last one like this. Negative 6 is greater than m minus 8. I want to get m by itself. It's just crooked. Sorry, it's crooked. I can't tell on my paper. There. I'm going to add 8. These go away. Negative 6 plus 8. If I'm 6 feet down in a hole and I come up 8 feet, I'm going to end up 2 feet above the hole. Bring down my sign. Bring down my m. Okay, this is great. I'm done with the math. But m is on the right, so I want to put it on the left. So I'm going to flip-flop those. And the mouth here is open towards the 2, so I want to leave it open towards the 2. Right? So here's my answer. So I'm going to find 2 up here, positive 2. Put a circle. There is no line underneath here, so I do not shade in that circle. And then I use the arrow trick. The arrow is pointing to the left. So it's all of these numbers. Any of these numbers can be solutions that would make this inequality true. Okay, I can pick negative 2 because it's in this shaded area, negative 2. Negative 6 is greater than negative 2 minus 8. Negative 2 minus 8 is negative 10. So is negative 6 bigger than negative 10? If you're 6 feet down in a hole and somebody else is 10 feet down in a hole, who's higher up? Person that's 6 feet down in a hole, right? So that is a true statement. Okay, then we have some stuff down here. It does not ask you to graph, just to solve. So we'll do a couple of these. Negative 3x is less than or equal to 8 minus 4x. Here we've got x's on both sides. We want an x on one side. So just like solving an equation, we want to get rid of the smallest x. So what's smaller, negative 4x or negative 3x? Negative 4x. When it's negative, the bigger number's actually less, right? Negative 4x. So we're going to add 4x here, and I got to do the same thing over here, and these cancel. So I'm going to rewrite this over here. Negative 3x plus 4x is just positive x, less than or equal to 8. And I'm done. That's my solution. I don't have to graph it. I'm done. If I wanted to plug this in, I could plug in 8 to this equation and it would be true. I could also pick any number less than 8 and plug it in, and it should still be true. Okay, number 8, 0.6n is greater than or equal to 12 minus 0.4n. I got to get rid of the smallest n, so I'm going to add 0.4n, same thing here. These go away. I'm left with 1.6 plus 0.4, 60 cents plus 40 cents is $1, right? So I am left with 1n. My sign stays the same. And then over here, these canceled, so I'm left with 12. Done. Okay, this guy, negative 8k minus 12 is less than negative 9k. I got to get rid of the smallest k. So I want to get rid of 9k, so I'm negative 9k, so I'm going to add 9k. Add 9k here. These go away. Negative 8 plus 9 is just positive k, and then it still has that negative 12 next to it. Keep my sign the same, and then there's nothing over here. And then I want to get k by itself, so I'm going to add 12 on both sides of my inequality. These go away. K is less than 12. Done. To check this, you can pick any number smaller than 12, plug it in. Let's say it's 1. 1 is smaller than 12. So negative 8 times 1 is negative 8. Negative 8 minus 12 is negative 20. Okay, negative 9 times 1 is negative 9. This is saying negative 20 is less than negative 9. That's true. If you're 20 feet down in a hole, you're a lot lower down than if you're just 9 feet down in a hole. So that's true. Okay, we have a couple more. I see a fraction here. So let's do that fraction. And then I'll do the bottom and we'll be done with this first video. All right, so number 11 here, z minus 1/3 is less than or equal to 4/3. Okay, and so to get z by itself, I have to add 1/3, right? So I'm going to have z minus 1/3 plus 1/3 is less than or equal to 4/3 plus 1/3, right? And then these guys right here get canceled out. So I'm left with z, these went away, bring down my sign, 4/3 plus 1/3. Remember, when the denominator's the same, you just add across the top. That gives me 5/3. Now, normally I would say, now change this to a mixed number, simplify. But in this case, it had an improper fraction in the problem. So if it has a number in the problem, you can keep it the same in the solution. Improper here, we're just going to leave our solution improper, right? So z is less than or equal to 5/3, and you're done. All right, define a variable, write an inequality, and solve each problem. Check your solution. All right, so this is just translating from verbal to algebraic. 13, a number, so when you don't know a number in math, you use x or any variable, decreased by 4, so minus 4, is less than, so less than 14. So here's our inequality. A number minus 4, a number decreased by 4, is smaller than, less than 14. 14 is bigger than this, right? So then to solve that, I would just add 4 to both sides. So I would get x, once I add 4 here, and I add 4 here, these go away, and I would get x is less than 18. Done. Number 14, the difference of two numbers is more than 12. Okay, one of the numbers is 3. So the difference of two numbers is more than 12, and one of the numbers is 3. So I'm going to say 3 minus x, the difference of two numbers, one of them's 3, 3 minus another number, is more than 12, is greater than 12. Okay, so I got to figure out what the other number is, right? I got to figure out this x here. So I've got, let me scoot it over wherever. 3 minus x, 12. I'm going to get rid of this 3, get rid of this guy. Negative x is greater than 12 minus 3 is 9. And then I need to switch the signs, right? So I'm going to add x here, add x here. 0 is greater than 9 plus x. And then I got to get rid of the 9, so I minus 9, minus 9. Negative 9 is greater than x, and then I have to flip-flop them, right? So I'm going to switch the x and the negative 9. And the mouth is open towards the negative 9 here, so it's got to stay open towards the negative 9. So the other number is negative 9. The difference of two numbers, 3 and negative 9, is 12 units, okay? Or is greater than 12, is more than 12 units. 42 is no greater than. What the what? What does that mean? Is no greater than. Well, if something isn't bigger than something, could it be less than that? If 40 is no greater than blah, 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 doesn't that mean it's less than or equal to that? If I said I want no more than 12 cakes for my birthday, cakes, not cupcakes, I'm a pig. If I want no more than 12 cakes for my birthday, does that mean I can have less than 12 cakes? Yeah, absolutely. Does that mean I could have 12 cakes? Yeah, I can have anything as long as it's not more than 12. So it means less than or equal to 12. So 40 is less than or equal to the difference of a number and 2. So x minus 2. Right? And so now I can solve. So I'm going to add 2 to both sides. 42 is less than or equal to x. Then I got to switch the sides. X is here, 42 is here. The mouth is open towards the x, so I'm going to leave the mouth open towards the x. So x is greater than or equal to 42 to make this true. 40 is no greater than, so it can be less than or equal to the difference of a number and 2. So what does that number have to be? 42. 42 minus 2 is not bigger than 40. It's less than or equal to 40. I hope that makes sense. Use your translating skills, right? Just kind of think through when you see these, for these symbols, the less than or equal to or greater than or equal to, kind of think through logically what it could mean. Is no greater than means it's less than, or it could be equal to. It just can't be more than. All right, let me know if you have questions.